here I'll use the variables W and B to represent the number of white and blue shirts that Jayant bought. Now this piece here, the average cost of all the shirts, because the purchase price was 1,000 per piece for white and 11.25, the average cost would be the total cost of white shirts, which would be 1,000 W. So it would be the total cost of white plus total cost of blue shirts divided by the number. So this would be the average. This is the weighted average cost. And then the market price is 25% higher than the average cost, which means market price would be a multiplier of 1.25 times that. So that's this piece here. And then he sold all the shirts at a discount of 10%, which means that the selling price would be then this times 0.9. So that's the selling price of each shirt. Now, they tell us that he made a total profit of 51,000. So total profit would be the total revenue generated, which would be this 1.25. So I'll move the numbers in front. The selling price times the total number of shirts, which is W plus B. And then I have to subtract the cost, and the cost is just this part here. So that's the total purchase price. So that's a relationship. You'll see this one drops out. This piece is the same. So I can factor that out. So at this point, it's just simplification. And then we'll have 1.25 times 0.9 minus 1. I mean, you can use a calculator here. This one is, or you can, I think I originally did it by rearranging it into fractions. So it's 0.125, which is really 1/8. So I'll move that over to the other side. And then I'll divide by 25 here. So that's 40, 25. So that's 45. This would give me 4. So 8 times 5, 10 times 4. Then I have another 5 that I could divide this by. And then I would get AW. AW plus 9B. And then this would be, again, you can use a calculator here. 102 times 32. So I get 3264. So this is our equation with these two variables where both W and B are constrained. Now our goal is to maximize the total number of shirts sold, W plus B, this part. Now you'll note here that the lower I can make B, the greater the value W would be, because that has a lower coefficient. So what I'll try to do is to make W as large as possible. So I'll move this term to the other side, then divide by 8, and you'll see this is divisible by 8. And notice B can only take those values for which W is an integer. So what's the least value of B that's possible? Well, that's 8, because then this will become an integer, 9 times 8 over 8. It'll become 9. And in that case, W will be 408 minus 9, which is 399. So this is what will give us the highest possible value for W, because it has the lower coefficient. And we want to choose B to be as small as possible. So that's what will give me the maximum value for W plus B, which is 399 plus 8, and 407 is the answer. In the end, I just want to show you also what my actual work looked like. So this is what I would actually be doing in the exam. Yes, it's a lot of work, and that's why some of these questions can be time consuming. But yeah, this is definitely a little bit harder question because of interpreting the statements here. But yeah, I mean, if you have time, I would probably attempt this closer to the end of the exam. So to summarize, the answer is 407.